Now we are going to work on we are going to learn on. So welcome, and so today we are going to learn like a secure cloud computing as a master class. So first, we are going to learn about the short concepts like data centers, cyber attacks, and hypervisors, and data ownership. The first topic will be on integrity and authentication. So these two, integrity and authentication, these are the core pillars. These are the core pillars. So that protects data and its verify identities in cloud environments. And coming to the integrity guarantees that data remains accurate and complete, and not only complete, it's see the completely unaltered during the storage, and even during transmission and processing also. So in cloud, it ensures this integrity ensures that malicious agents or errors do not tamper with. So that it will ensure that the files are not getting tampered, and it is strictly verified. So it is in this integrity security pillar will strictly verified using cryptographic hashes. So we have cryptographic hash. We are having cryptographic hashes. By using these cryptographic hashes, like for example, uh, SHA 256. This SHA 256 is the standard cryptographic hash. SHA stands for secure. SHA secure hash algorithm, and this 256 stands for 256 bit. So this is widely used cryptographic hash function. So with respect to the input size, and dramatically maps to unique fixed 256 bit, nothing but 32 byte output, input of any size, and it's going to be 256 bit, that is nothing but 32 byte output. And even it will use digital signatures. It will use digital signatures also. Addition to cryptography hashes like the SHA 256 digital signatures, and it will use strict versions. So they will see whether the strict version control mechanism is present or not. Strict control mechanism is present or not. Okay, if this particular, so because if a single single byte of data single byte of data is modified. So with respect to without following a secure hash algorithm or not having not using like this and strict version control mechanism, there will be chance of single byte of data single byte of data getting as a result there will be complete changes. So if this single byte of data is right, there will be completely digest changes due to tampering, due to exposing to tampering. That's about integrity. Next, about authentication. This is majorly focus on confirming the true identity. True identity. True identity of the user and application or a system for granting access. For granting access to any cloud resource. So this authentication will be answer for yeah, so access to any cloud resource. So in cloud platforms, authentication is implemented through robust mechanism. What are those robust mechanisms? One is MFA. MFA multi multi factor authentication and SSO. single sign on. And next identity federation protocol. Identification federation protocols. So it can be SAM, SAML, or OAuth. So we have like for authentication, authentication is confirming the true identity of a user, application, or system before granting access to any cloud resource. And coming to like it can be cloud platforms. So authentication for cloud platforms, authentication is implemented through robust mechanisms like MFA, multi-factor authentication, SSO, single sign-on, and identity federation protocols like SAML or OAuth. Federation protocols. Next, we will move on to the key differences between integrity and authentication. So, coming to integrity, it is data centric. Data centric means but ensuring the message or data, ensuring the message and data has not changed, has not changed. While authentication it is identity authentication identity centric. So where verifying the entity verifying trying to access the data. So where integrity is data centric, ensuring the like where integrity is data centric, ensuring the message or data has not changed. Integrity is the data centric, ensuring the message or data has not changed. Where authentication is a identity centric, verifying the entity, trying to access the data, verifying the entity, trying to access the data. So both must work together. So they both must work together. For instance, digital signature, authenticates indicates the sender while simultaneously proving data integrity. So both works together. For instance, a digital sign, both must work together. For instance, a digital sign authenticates the sender, a digital sign authenticates the sender, while simultaneously proving data integrity. So both must work together. For instance, a digital sign authentication will the digital sign authenticates the sender while simultaneously proving data integrity. So both must work together. For instance, a digital sign authenticates authenticates the sender, and a digital signature authenticates the sender while while simultaneously proving the proving the proving data integrity. While simultaneously data integrity. Let us try to understand with a practical with an IT example. Let us try to understand with an IT example. So let us consider integrity. Well, let us consider the integrity at data verification. Let us consider integrity as data verification and authentication as identity validation. So these are core security pillars. It's become core security pillars that protect code repositories and verify developer logins in GitHub Enterprise environment. GitHub Enterprise environment. Data verification guarantees that a code commit remains functional and completely unaltered during pushes, pull request, or automated building. So in pipeline, it ensures that rogue scripts or network drops do not corrupt. So it is strictly verified using system checksums like SHA-256 and commit signatures and strict version control branching. If even a single line of code is modified, the resulting build hash changes completely, exposing the tampering. And coming to identity validation, on the other hand, so this focuses on confirming the true credentials of an engineer so with an API token or CI/CD runner before granting access to any cloud repository. And in production platform, validation is implemented through robust mechanism. Validation is implemented through robust mechanism such as multi-factor authentication, single sign-on (SSO), and particular provider certification like Okta or Microsoft Entra ID. So coming to the key difference, data verification is a code-centric, ensuring source files or script have not changed, while identity validation is people-centric, verifying the engineer when to deploy the code, but both must work together. For instance, like a SSH signing key validates the developer while simultaneously proving the code base integrity. As next, we are going to was the first concept. The second concept, guest hopping. So this guest hopping will be like a VM to VM hopping, virtual machine to virtual machine hopping, and this is nothing but this is a highly specific security exploit. This is a highly specific security exploit. It's going to be unique to virtualized environment environments. These are virtualized environments, unique to virtualized environments. So this particular highly specific secret exploit, like unique to a particular virtualized environment. Okay, so it occurs. It occurs when an attacker successfully compromises so one machine, that is nothing but the guest, and so it occurs when an attacker has one virtual machine, the guest, and will be leverages that initial foothold laterally and gain unauthorized access. హలో చెప్పండి
సార్ అది రేపు ఎగ్జామ్ క్వశ్చన్ లైక్ క్వశ్చన్స్ ఏమైనా ఉన్నాయా?
వాట్సాప్ గ్రూప్లో ఉన్నాయి, చూడండి ఒకసారి.
చెక్ చేస్తున్నా సార్, కాల్ చేస్తున్నా. ఏ గ్రూప్?
మనది ప్రైవేట్ గ్రూప్ ఉంది, ఆ గ్రూప్లో ఉంది.
ప్రైవేట్ గ్రూప్? ఓకే సార్. ఇది మొన్న ఎగ్జామ్ మ్యాప్ బిగ్ డేటా
అన్నిటికన్నా ముందే పెట్టారు సార్.
అవునా? అచ్చా,
డాక్యుమెంట్
ఇప్పుడు చూసిన
move line and gain unauthorized access. Unauthorized access to a to a neighboring virtual machine. So which is running on the physical hardware. So the mechanism of attack, how this particular attack is going to be done. In standard cloud environment, user isolation is enforced by hypervisor, and it's going to be ensured that each tenant so each tenant operates independently. So this guest hopping, so this guest hopping exploits vulnerability vulnerabilities. So this exploits vulnerability. So like this isolation boundaries. So the isolation boundaries. So the isolation boundaries fail. This isolation boundaries. So bypassing hypervisor is a hypervisor isolation. So there will be hypervisor isolation. So that will be bypassed by guest hopping by the attack. This bypassing hypervisor is nothing but instead of attack instead of attacking like virtual machine, instead of attacking the virtual machine, so when attacking the root host, root host directly. So root host directly as in a as in a full hypervisor escape in a full hypervisor escape. So the attacker specifically exploits leaks exploits leaks or vulnerabilities in shared hardware infrastructure, such as so it is going to the attacker specifically exploits stuff attacking the root attacking the root host directly as in a full hypervisor escape. As in a full hypervisor escape, the attacker specifically exploits leaks or vulnerabilities, which are like the attacker specifically exploits leaks or vulnerabilities in a shared hardware infrastructure, such as shared shared memory rings, network vSwitches, or shared clipboards. Shared clipboard to hop directly into another tenant's space and exploiting one is bypassing hypervisor isolation. Next is exploiting shared resources. So binarizing or manipulating shared cache by analyzing or manipulating analyzing or manipulating shared cache. They are manipulating shared cache and CPU timing or misconfigured misconfigured virtual networks. So the bypassing hypervisor instead of attack like bypass uh, bypass bypass hypervisor isolation instead of attacking the root host directly as in a full hypervisor as in a full hypervisor escape. The attacker specifically exploits the attacker specifically the attacker specifically exploits the attacker specifically exploits leaks or vulnerabilities exploits leaks or vulnerabilities in a shared hardware infrastructure. Attacker specifically exploits leaks or vulnerabilities in specified specified hardware like data specific exploit leaks or vulnerabilities in specified hardware infrastructure such as shared memory rings, network V switches, or shared clipboards, such as shared memory, shared memory rings, network V switches, shared memory, shared memory rings, shared hardware infrastructure, vulnerabilities in hardware infrastructure such as shared memory rings, network V switches, or shared clipboards to hop directly into another tenant space. Shared clipboards to hop into other clipboards to hop directly into another tenant space, bypassing hypervisor isolation. Like attacking instead of bypassing hypervisor, bypassing hardware, bypassing hypervisor isolation instead of attacking instead of attacking instead of attacking the attacking attacking the root host directly instead of attacking root host directly as in a full hypervisor as a full in hypervisor escape as in a full hypervisor escape. The attacker specifically exploits the attacker the attacker specifically exploits the attacker specifically exploits leaks. The attacker specifically exploits leaks or vulnerabilities. The attacker specifically exploits the attacker. The attacker specifically exploits the attack. The attacker specifically the attacker specifically the attacker the attacker specifically the attacker specifically exploits exploits leaks. The attacker specifically exploits leaks or Vulnerabilities in specified hardware. Vulnerabilities in specified hardware. Vulnerabilities in specified hardware resources. Vulnerabilities in specified hardware resources. Vulnerabilities in vulnerabilities in shared hardware infrastructure such as shared memory, shared memory, shared memory rings, network vSwitches, or shared clipboards. So to hop directly into to directly hop directly into another tenant space, bypassing hypervisor isolation instead of attacking direct instead of attacking so give instead of attacking instead of attacking instead of attacking root host instead of attacking root host directly as in a full hypervisor as in a full hypervisor attacks like the attacker specific the attacker specifically exploits the leak or vulnerabilities in vulnerabilities in shared hardware infrastructure such as shared, shared hardware infrastructure such as uh, such as shared memory shared memory rings shared such as shared memory rings network switches shared memory rings shared memory rings like network vSwitches or shared clipboards. So to hop directly into another tenant's space and exploiting shared resources by analyzing or manipulating shared cache, CPU timing, or misconfigured virtual networks. Shared cache, CPU timing, or misconfigured virtual networks. Okay, by analyzing or manipulating shared cache, like what shared cache by exploiting shared resources, exploiting exploiting shared resources, exploiting shared resources by exploiting shared resources, analyzing or manipulating shared cache, exploiting shared resources, exploiting shared mm, exploiting shared resources, exploiting shared resources by analyzing or manipulating shared cache, exploiting exploiting shared resources, exploiting shared resources, exploiting shared resources by manipulating shared cache, CPU timing, CPU timing or virtual networks, misconfigured virtual networks by exploiting shared resources by analyzing or manipulating shared cache, CPU timing or misconfigured virtual networks. A malicious a malicious guest VM circumvents traditional access control. Circumvents traditional access control. Access controls. This is going to happen by bypassing hypervisor isolation, and by exploiting shared resources. And let us see impact on cloud security. Let us see impact on cloud security. Impact on cloud security. One is breach of confidentiality. One is breach of confidentiality. One is breach of confidentiality. So it breaks the fundamental multi-tenancy promise of the cloud. It breaks the fundamental multi-tenancy promise of the cloud, exposing sensitive data, cryptographic keys, or corporate applications of neighboring tenants to malicious actors. It breaks the fundamental multi-tenancy promise. It breaks it breaks the it breaks the fundamental It breaks the fundamental multi-tenancy promise of cloud, exposing sensitive data, cryptographic keys, or corporate applications of neighboring tenants to malicious actors. Breach of confidentiality breach of confidentiality. It breaks the fundamental multi-tenancy of a cloud. So breach of confidentiality. It breaks the fundamental multi-tenancy promise of a cloud. Promise of the cloud, exposing sensitive data, cryptographic keys, or corporate applications of neighboring tenants corporate applications of neighboring tenants to malicious actors. And next, lateral attacker vector. Lateral attacker attack vector. Lateral attack vector. Once the hop is completed, once the hop is completed, the attacker can use the newly hijacked guest VM. Once the hop is completed, the attacker can use the newly hijacked guest VM to execute malicious code or cause a denial of service across infrastructure lines. Once the hop is completed, once the hop is completed, once the hop is completed, the attacker can use the newly hijacked guest VM. The attacker can use the newly hijacked guest VM to execute malicious code or cause a denial of service across infrastructure lines or cause a denial of service across infrastructure lines. Once the lateral attacker vector. Once the hop is completed, lateral attacker vector. Once the hop is completed, the attacker can use the newly hijacked guest VM to execute malicious code, or cause a denial of service across infrastructure lines, cause or cause a denial of service across infrastructure lines. Lateral attack vector. Once the hop is completed, the attacker can use once the hop is completed once the hop is completed the attacker can use the newly the attacker can use the newly hijacked guest VM to execute to execute to execute malicious code, or cause the denial of service across lines. And here is the like, bypassing mm, bypassing the hypervisor isolation, exploiting shared resources, uh, like like impact on impact on impact on cloud security, like breach of confidentiality, lateral attack vector. So one is bypassing the hypervisor isolation, exploiting shared resources, impact on cloud security, breach of confidentiality, lateral lateral attack vector. Let us try to understand within a real time information, like real time IT example. So this guest hopping can also be called as tenant jumping. Okay, so this is also referred to VPC to VPC hopping. Okay, so here the highly specific network exploit, like unique. This is going to be unique to multi-tenant cloud environment. This is going to be unique to multi-tenant cloud environments. So it is going to occur when an attacker successfully compromises one client instance, the tenant, and leverages that initial foothold to move laterally and gain unauthorized access to neighbor client database running on the same underlying physical server. The mechanism of attack. So in a standard cloud environment, tenant isolation is strictly enforced by security group. This tenant isolation is strictly enforced by security group, ensuring that each business operates independently. How the tenant jumping exploits vulnerability with this network boundaries where one is bypassing network isolation. Instead of attacking the root firewall directly as a full perimeter breach, the attacker specifically exploits leaks or vulnerabilities in shared cloud infrastructure, such as shared database clusters, routers, or shared IAM roles, to hop directly into another company's space and exploiting shared resources by analyzing or manipulating shared storage, API gateways, or misconfigured peering connections. A malicious client instance circumvents traditional access control. So coming to impact of cloud security, so breach of confidentiality, it breaks the fundamental multi-tenancy promise of cloud, exposing sensitive cryptographic keys or corporate applications of neighboring tenants to malicious actors. And lateral attack Later, once the hop is completed, the attacker can use newly hijacked client instance to execute malicious code or cause a denial of service across infrastructure lines.